Hi everyone, this is Ella Finlay from Group 2, and we would like to introduce you to our model in a bit of a fun way by showing it off with the Sims. We were asked to design and analyze a portal frame structure that is 20 meters in length, 14 meters wide, has an eaves height of 10 meters, a 6-degree angle roof pitch, and a rafter load of 10 kilonewton meters. Additionally, our model contains an 8x5 mezzanine level, 4 meters from the ground with access stairs leading up to it. Here you can see some of our floor plans and elevations. Firstly, we have level 0, and then level 1, where you can see a bit of the roof and some of the mezzanine. Then we have the eastern elevation, where you can see some doors. And lastly, the southern elevation, where you can see a few windows.
For the interior of the shed, we decided to place mezzanine on the corner and not in the middle of the shed, to evenly distribute the weight across the columns and maximize the space inside the property. For the structure of the shed, we decided to go with a 356 by 171 45 universal beam for a restrained column and 305 102 by 25 universal beam was selected for the rafter. After reviewing the Zed's user guide for design and installation, purlins that were chosen were the ZC150-24. This allowed for an inward load of 2.52 kilonewtons per meter and an outward load of 1.23 kilonewtons per meter. Based on the light 24mm thick spandex wall, we decided to choose the light gauge lip channel LL1022, as this provided the required strength while also being cheaper and easier to handle on the construction site.
Here you can see the basis of our space gas model. The dimensions were determined based on those given for our Revit model. Additionally, our columns, rafters, purlins, and girts were based on those chosen for our Revit model. In some cases, space gas did not offer the exact size needed, in which case we decided to size up to the next closest available option.
Hi, my name is Victoria Finlayson. Within this project, we were tasked with designing the apex, rafter to column, and column to concrete plinth connection using space gas. All data was analysed according to the space gas pass or fail criteria, which is based on Australian Standard 4100. Here we can see the apex connection. As stated previously by Elle, please note that where space gas did not offer the exact universal beam needed, we chose to size up to the nearest option. This connection passed with a utilisation ratio of 0.96. Here we can see the rafter to column connection. In this case, we used a bolted end plate. This connection passed with a utilisation ratio of 0.86. Here we can see the column to concrete plinth connection, which includes holding bolts and a pinned base plate. This connection passed with a utilisation ratio of 0.4. Therefore, per the criteria, it is clear that each connection is viable.
Once all the parameters have then been loaded into space gas, we can run a linear static analysis. Running a linear static analysis allows us to see our deflection diagram, our bending moment diagram, as well as our shear force diagram. We can also run a check to ensure that our model meets Australian standards. This includes mapping the wind paths in the Illawarra region. Once space gas has run the analysis, it will show us all the members that do not meet Australian standards. As you can see on the right, the pink and red indicate a fail. Now we run the analysis again, except this time we give space gas the permission to change our members to ensure that they meet Australian standards. As indicated on the right, a blue is a pass. Here we have the previous sections for the model, and these are the sections after space gas has made the changes.